Whoa! Hello, everybody. Welcome to another Percona live stream. We are at the top of the hour, so thank you for joining us today. I've got Ege and Vinodh with me from Team Percona. So hello, guys. I'm going to go ahead and I'm going to turn on the chat so we can see anybody who pops in here and asks us some questions. So a few things before we begin. This is our third meetup. This one is focused on Mongo. So every month we'll have a Mongo focused one. Every month we'll have a Postgres. Every month we'll have a MySQL. Every month we'll have an observability and monitoring one as well. So, hopefully you're here to join us live. If not, you can check this out on YouTube. And if you're watching there, feel free to reach out. We'd love to have you on as a guest. So come on and chat with us later on. Wanted to actually start with a topic that has nothing to do with MongoDB or databases or open source in general. All right. Now, you might hear some construction stuff going on around the house here today. I don't know if you will. It's hit or miss. So yesterday had a slight plumbing issue, and now they're tearing up my floor downstairs. So, I might get called away. And so, we might have, times when I disappear for a second. We'll see. But I decided to work in my plumbing issues into a technical talk. And so this is my challenge for today. I wanted to make an analogy that was interesting and relevant to today's topics. So at first I thought, hey, here, I've got a bathroom that basically had some plumbing issues. And so they had to tear out the floor, take the toilet out, take all the stuff out to fix it. And I thought about using this as a good analogy for high availability. So we failed over to our second toilet, our second bathroom down the hall, and we have sharded bathrooms, like the half bath with no shower and the full bath with shower. So we've sharded, so we have different feature sets. So I thought that could work. But then I found out what's actually the problem, and it took me in a completely different direction. So, it turns out, and I don't know, Vinodh or again, do either of you know much about like plumbing? Are you guys plumbing experts at all? No. Okay. So I was not aware of this, but it turns out that from a plumbing perspective, toilets sit on like what they call this O-ring, and then there's like this inner ring that's made of wax or something. And I didn't know that's something that I didn't know. And it turns out that when we bought this house a couple years ago, it was a new build, and they actually never completed it. They missed some of the parts and they missed some of the setup. And so what's been happening is that part actually keeps the plumbing from leaking. And so over time, things started to leak, and between the floor and the subfloor, little by little, water and other things started to get in there because they missed this relatively small component that was supposed to be put in there. So, for a couple years, it worked, no problems, no issues. There was no signs of any issues, anything like that. And then all of a sudden, one day, it just, you start to notice like the floorboards buckle, you start to notice water. You're like, what the heck is going on? So you call the plumber, they come out and they go, oh, wow, this has been happening for a while. You just didn't notice it because it was all kind of below the surface. And this kind of reminded me of, one of the big problems that I see in databases right now is how many times do we sit there and say, hey, you've got these problems. There's a scalability issue. There's an issue with your application performance. There's an issue with, your availability. And it turns out that the application was never designed properly. And in the case of my toilet, like you literally, had something that worked for 2 years without a problem, but it reached a point of saturation or a point that it became such a critical issue that it overflowed and started to cause other issues, right? And so from that perspective, we have a lot of databases that are out there, a lot of database infrastructures. Developers are out there, they're developing all kinds of cool things. A lot of times they're not thinking about the design aspects of it. It works for a couple of years. They probably move on to another job. And then someone has to come along and they're like, oh my God, why did all this stuff break? And you realize, whoa, this was never designed to handle this the way it was. It was a bug that it worked for 2 years. right? It shouldn't have worked for 2 years. And, when we talk about Mongo, and today our topic is really Mongo, Mongo is designed for developers, right? That's, its core audience. It is so easy to use. It's so easy to get started. But one of the things that I continually hear over and over again from a Mongo perspective is, hey, people don't think much about the design, because it's just, you take your JSON, you throw it in the database, and you run with it. So it's designed to not have to think about those database components. And so I'm curious your experience in that. I know it happens in MySQL. I know it happens in Postgres. In MongoDB, how often is that design causing issues?
So Vinodh, do you want to start?
Yeah, okay. So a lot of times, like in MongoDB, like the design is the main part when you are actually looking for the performance. Okay, so as Matt said, like if you are going to have a bad design or bad topology, then you're not going to maybe you're not going to see the consequences immediately, but later you will be seeing, like for example, you may see your queries running faster when you are actually implementing the application for the first time. But in some days, after getting some new data into the database, you may see some kind of issues, because like your data is not actually distributed properly in the sharded cluster. For example, here when you're not having your proper the cluster is not designed in a way that your data is scattered properly. Okay, and your load is not also going to scatter properly. Okay, and in that case, when you're going to have the application getting the data, for example, if it is going to write or going to get some data, fetching the data, so it cannot go into the right place and get the data and come within time which is expected. Okay, so it may cause, because in long run your data is not actually sharded properly, so that what happens, like because of the wrong shard key, okay, and because of your queries which is not using the proper shard key in the filter, so that can cause your query scatter across all shards. Okay, and but when you're designing your application and the topology very properly, you can put your query into the particular shard where your MongoDB can directly go into that particular shard and get your data and give it to you back within no time. But when it is not designed properly, your data is going to scatter across all shards, which is going to make difficult for your application, and it hits the performance very hard. And also,
so Vinodh, this is like a classic Mongo problem, right? So in older versions of Mongo, because they just introduced this, you used to have resharding be a significant issue from a shard perspective.
Yeah.
Right? Because you would get these imbalances where, one or two nodes would have like so much hot data that it couldn't handle it. But, there was a whole art to trying to get that to like, to be distributed properly. But now they've introduced this new feature in the latest versions of Mongo. Have you tested that out? Have you played with it? Can you tell us a little bit about the resharding capabilities in the new Mongo?
Yeah, it's been a pain point in earlier version, like when you find out when you found that your shard key is not the proper one, you want to reshard that one. Okay, or else if you want to change the shard key in earlier versions, you need to actually drop the collection and recreate with a new shard key. Okay, and as you said, like in 5.0 there is an option which we can reshard, or which we can redefine the shard key online itself without dropping and recreating the shard key. The problem with this here is, like even though you have opportunity to reshard your collection, the pain point is very high. Okay, for example, if you have a data, for example, if you have a data of 10 GB or 20 GB, it would be faster. But if you have data in terabytes, you just think about the pain point where like it would take long time to reshard. Also, you would need the at least 120% of the data size, the empty disk space inside the OS level. Okay, so it would take that much, at least that much space to getting recreated. Okay, and that's there. And again, the other main point here is like when you are actually doing the shard key changing, okay, and you need to actually slow down all your application load to the database, so that it won't actually interrupt with the process of changing the shard key as well. So to avoid these pain points, it is better to have that design before coming into the production. That means like before doing that, do your R&D and do choose your shard key properly before itself.
So sharding is an art in and of itself. But I mean, just from a database design perspective, I continually hear from a Mongo perspective, often people don't think about adding indexes. Sometimes they don't think about, the actual structure of their documents. And those two are very critical things that people often overlook. Do you have any experience kind of running into problems with those?
Yeah, a lot of problems because in my support, like I have seen a lot of cases where people faced issue with that hot shard. Okay, hot shard in the sense like all your data application request goes into the particular shard. For example, if you have like 20 shards in your sharded cluster, okay, but all your load goes into the particular shard, which makes that shard unresponsive for some time. Okay, that is because all your data which you needed by the application is exist on that particular shard. Okay, we call it as a hot shard. Okay, so in that case it is important for you to split up your data across many shards, so that you can split up your load as well to many shards. Okay, for that you need to make sure that there are ways that you can actually split up these things. You can pre-shard or else you can define your chunks, so that you can put your data into multiple shards earlier itself. For example, if you are going to insert or put a new writes into the shard cluster, it's going to get into one shard, and the balancer is going to migrate everything into the other shards. If you are going to predefine those chunks, the data whichever you're going to write will go into the respective shards in previous stages itself.
Vinodh, shards aside for a second, just from an from a performance, a scalability, design issue, without shards, without shards, it doesn't matter. I mean, like that actual document design is often overlooked, right?
Yeah, that is because like it's not like RDBMS where you have a predefined structure. So okay, and other thing is like when you are facing the issue only, you will come to know, okay, you need to create index on that. Okay, so it's only when you're having the problem you come to know, okay, this is the problem, so we need to create index. Then only you are going to get advice from us and going to create index on that. So instead of that, do some testing on the application side and then create index previously itself, so that you will have no issues on that. Also, you can plan like a bulk update, okay, or bulk inserts, so that it won't cause issues much into the application side.
Okay, and Ege, you are an application developer formerly. You used to be an application developer, correct?
Yeah.
And so, from your perspective, tell me a little bit about your experience from a developer perspective in Mongo.
So, to be honest, I found myself defending against using Mongo in many times. Because
wait, why would you do that?
Because as a web developer before, many developers, as you said, loves Mongo, and they want to run away from this relation database. They don't want to have this strict schemas, have these foreign keys, and they want to run away from them. They want to have a JSON document and put all things to that. But in my use cases, that was the cause of the duplication in the data. So we need to duplicate all the data, and we need to update this document. So we need to update this 1 million of documents because the data is duplicated. So I am against using Mongo or NoSQL databases in general to escape from the relational database perspective. But some data, I guess, is more suitable for Mongo. Like you have, let's say you have a collection of products, and you need to be flexible with the schema, with tags, with prices, and specific fields for different countries. Maybe it's really a nice way to solve this problem. But to run away from this relational perspective, it's anti-pattern for me.
Yeah, and I think that this is a common thing, right? So this gets back to that, again, the design discussion that I mentioned, which is some people just, it's the old school mentality. I used to work at an Oracle, shop, and it was an Oracle shop, which means any database, any workload was Oracle, right? And I think that people fall into that trap still sometimes where it's like, we have this in our environment, we must use it. But really, the great thing about the current database landscape is there is a database probably for every job you want to do. That's also the most scary thing about the current database landscape is there's so many of them. But, you look at the differences between, let's say Cassandra, MongoDB, Redis, Elastic, all of these different, databases that are out there, they solve different purposes and have different use cases. And each one is really designed to handle a specific workload. And, sometimes choosing one just because, you want to escape the other because I don't like them. I hate this database because, I think that is the wrong mentality, and that sets you up for that design decision that maybe a couple years down the road is going to come back and bite you. Right. And I think that's a mistake we've all fallen into in the past because we all have our prejudices on what we consider a better database or what we're more comfortable with. And in a lot of cases, someone who is a MySQL DBA is going to choose MySQL. Someone who uses Mongo all the time is going to choose Mongo, even if they're not necessarily the right one to use for that particular application.
Yeah.
And so,
no,
go ahead.
Yeah, I was from this application perspective, Mongo can be a wrong choice. Maybe MySQL may be a wrong choice for some use cases. But from infrastructure standpoint, Mongo is really a nice database about scaling, about replication, about sharding, as Vinodh said. Is because I think it's built from this with these ideas from the first day, and it's a really nice database to scale, to manage. I think so. I really like Mongo, so don't get me wrong.
Well, and you had said that really what you see in one of the awesome things from a Mongo perspective is how easy it is to run the infrastructure.
Yes. So I will be talking about this new feature in our operators called cross-regional replication. I may say cross-cluster replication, so it's a synonym for me. Please don't confuse. Basically, this feature is with our Kubernetes operators. You can have 2 clusters, one in Kubernetes, one maybe in Kubernetes, maybe in some on-prem, some Linux server, or a bunch of Linux servers, and you can configure replication between them. And I can tell how easy it was with Mongo. It was a really nice experience because we did the same feature in our PXE operator, and it was harder than that. Bulat, one of my teammates, did this feature in PXE in recent release, And I reviewed the code. It's much more complex. It was much more complex in PX. But Mongo, it was just put them in same network and configure with authentication this SSL certificates, and that's all. The replication was really easy after that. So Mongo, in that perspective, about this replication, we even support shards with this feature, and it was an easy thing to do. So I really liked Mongo after that feature.
And so so what we're talking about here is you've got two clusters across vast reaches of time and space. You've got one on, let's say, in Europe, one in South America, right? So you've got these two clusters, and you're talking about being able to set up geographically redundant clusters across these two geographic regions.
So Mongo has this concept of replica sets to configure replication and have some primary and secondaries. So we put all these different regions in same replica set, so they can replicate data between them, and all the writes continuously replicated between all these regions, all these data centers.
Okay, and so adding to what Ege was telling, it's a great feature that MongoDB can replicate across multiple regions. And also there is a feature called zones, okay, or else in replica set you can use tag sets, or else in sharded cluster you can use zones, okay. With using that, you can actually redirect all your data load to the specific region. So instead of going into for example, if the application resides on South America, if you want to access data from South America, you can redirect all those load to South America regions MongoDB instances by using these tag sets or zones, okay. And by using that, you can actually split up everything, and then also you can keep specific data only into the specific region. You don't need to keep all that.
So if you want just your South American users to hit those, then you can. And that means that both sides are live and accessible, and you can read and write from either side.
Yeah, you can do that. Yeah, that's why I told you, right? It's by using zones you can do that. When you're using replica set, there is no other way. You have to replicate to all the nodes, but you can use tag sets to redirect all your load to the particular nodes. Okay, that you can do.
Okay, and so this is a tech preview right now, right, Ege?
Yes, we will releasing this feature as tech preview because it's a complex feature, and we don't want people to rush with their production clusters to it, and we needed to limit the functionality of this replica clusters. If you deploy them with our operator, we need to limit many functionality of our operators, like backups, restores. The smart update feature is because the smart update is a feature to upgrade your Mongo database to next major version and have this restarts of your database nodes without with minimal downtime, without many context switches in clients. So we needed to limit this functionality for this release too. And we are releasing as technical preview. But in the next releases, and if people will start using it in their maybe testing environments, staging environments, and they can provide feedback for us, and the feature can be mature in the next release.
And so, okay, so this is designed right now to be in the Kubernetes operator, but not everyone runs in Kubernetes. Some people are afraid to run in Kubernetes. Other people find it daunting to potentially move to Kubernetes. Maybe tell us a little bit about that process of, is it easy for people to move? Is it easy for people to get started with Kubernetes and Mongo?
To get started, it's easy, but many people have this production environments currently. So this feature is primarily designed for those people because migrating to Kubernetes is the scariest part. And you have a big data, like gigabytes, maybe terabytes of data, and taking dump of it and putting some object storage in some clouds is really scary. I was a DevOps engineer before Percona, and I wouldn't want to do that because it will be a big downtime. But with this cross-cluster replication thing, you can replicate the data, and you can minimize the downtime when you are trying to migrate. It's a nice thing to do, and people don't need too much to just try out with their real data. They can try out Kubernetes with their real data. They can replicate, and they can see the performance on Kubernetes. They can stop replication in any time and to see how their applications behave. So it's more than easy now to migrate or try out Kubernetes.
Yeah, even in support, I have seen a lot of customers started using Kubernetes. Even I have seen a customer who is using integrated PMM with Helm chart and monitoring the MongoDB instances from Kubernetes. So people are started moving into Kubernetes nowadays.
Okay, and Vinodh, so we talked about these geographically redundant setup in Kubernetes, and I know that you have a passion for sharding because you've already talked a little bit about sharding earlier. Is this something that you're seeing the geographically distributed shards yet?
Yeah, so I've seen that because even I have seen a customer who is using that zones. Okay, so that he is having some data in Asia and Europe, as well as in I think in America side or something. Okay, so the only thing is they need to properly mention the zones, the tag set. So when they are actually inserting the data, it will go into the respective shard. And also when you're using the read preference, there is a thing called read preference. You just need to mention the proper zone ID so that it will redirect to the respective instance in that region. So that is fine, but only the pain point here is you need to have a proper HA there. Otherwise, what will happen if you are going to lose some data or lose some instance, you will not have a backup. Okay, so
let me ask you a question on that. This is an interesting question. So I think some people get this wrong. Is sharding in and of itself a HA strategy?
No, not at all. So the thing here is the people think that deploying the sharded cluster itself is a HA. No, so it's a kind of a MongoOS. There are three components: MongoOS, config server, and shards. Okay, within that config server and shards, you need to put everything into a replica set. For example, if it has 3 shards, shard 1, put it in a replica set, shard 2, put it in a replica set. So something like that you need to config servers, you put it in a replica set, so that even one of the server goes down, you can have other server to take over that one. So you need to make sure sharded cluster is the one part, and adding replica set to that is the another part.
Okay, and so so there is 2 components here. You can have HA without sharding. You can have sharding without HA. And just because you have sharded data doesn't mean you have high availability. Because if one of your shards goes away, then everything is kind of borked.
Yeah.
Right? Unless you have the HA setup. So it's an important distinction, because we have gotten that question before, on our community channels, where it's like, do I need HA or do I just need sharding? And it's not an either or decision. You probably might need both. You at least need HA. Let's be honest. So you're setting up this sharded cluster. We talked a little bit about shard key. How do you find out if your sharded cluster is overloading a single node or if it is imbalanced? Is there some way for us to identify that?
Yeah, actually, that's why it's very important to monitor your sharded cluster. Okay, so PMM is a very good tool, great tool actually to monitor these things. Okay, and when you're actually having this slowness in the application side, you can go into the PMM and check where is it actually, where are your queries going, and whether you can check whether it is ending up with one shard, or else if it is whether it is targeting to one shard, or is it broadcasting to every shards. For example, sometimes what happens when you are not specifying the shard key, or else if your shard key is not is the proper one, it may broadcast your request to all shards. So that would take time to gather all the data and put it into one place and do the operations. For example, if you are doing sorting or if you are doing grouping, it has to gather all the data, so it has to do all those things, and when you are getting the data to the application, it would be very late. Okay, so that's where PMM comes very handy for you to identify these things. And other than that, there is a FTDC which is available in every MongoDB instance, so you can go and then get that FTDC data and check the data, and you can see whether what happened behind the scene.
Well, so this is an interesting question. So let me, so when we talk about like that imbalance, right? So there's two types of imbalance, really, right? So one is you have the imbalance with, the data for that particular shard is busy, but you could also have it where the one node in the sharded replica set is busy as well. Is that correct? If you don't have connection pooling set up properly, you don't have load balancing set up properly, you could overload one node of a replica set of a sharded, data set. Is that correct?
Yeah, kind of like for example, like the application setup mostly is like when you're not getting the data within proper time, it will recreate the request, or else it will resend the request again. So when one of the shard is actually overloaded and the application is waiting for that data, it will resend the request again. So it will create the consequence of this is like instead of getting the request within one shot, it will put over and over request again, and it may grow without any or like infinity times. So that's where the connection pool setup, putting the cap is very important. And within that time, so when you're actually setting the Mongo is connection pool, for example, that task executor pool, and when you're putting cap on that, when your application is requesting more than what it is set up, your MongoDB will not be overloaded, because your Mongo is not going to get more requests than it is set. Okay, so that's where these connection pools come handy with you.
Okay. So, I don't see any questions popping up in our chat. So I wanted to give both of you the opportunity. Like we talked about a few different things. We kind of touched on your topics. Are there things you would like to share with the community that you didn't get an opportunity to talk about yet?
The one of the main thing is like a backup. Okay, so because a lot of customers,
consistent backup is a problem, especially when you have like a bazillion nodes that you're trying to get it consistent across all of them. It's a good point. Yes, tell us about it.
Yeah. So what happens, like a lot of customers I have seen having issues with having a proper backup. Okay, so for example, having Mongo dump is they think like having Mongo dump is enough for them, but it's not. For example, especially in sharded cluster environment, because it is important for you to take consistent backup across every shards, so that when you are doing the restore, it happens properly. Okay, so taking backup is important, and testing is another important point, and make sure that the restore happens properly so that you can rely on that backup method. Okay, so that's where our PBM comes handy. That's a Percona backup for MongoDB, which is very good tool, and you can use it for replica set as well as for your sharded cluster. So you can have multiple, you can take multiple backups with that, and even you can have an incremental backup with that, which we call it as a PITR, which is point in time recovery backup. So which tails the oplog and takes backup from oplog for every 10 minutes, so that you can restore to up to a point. Okay, and when you want to do a restore, you can restore up to a point where you want, if you have that backup properly. Okay, so this is important for you to have a proper setup. So having deploying the setup is not only important, having a backup is also equally important for you to restore when you have a difficult times.
I'm testing the backups, right, Vinodh?
Yeah, definitely.
Everyone gets the backup, but
what? Testing the backups? You don't want to test your backups, do you? That's
if
not
you
something
don't
Yeah,
test
definitely
the
you want
backup,
to.
you don't have a backup.
Well, how do you test a backup that's a terabyte?
Yeah, it can be hard for terabyte backup.
But I mean, how do you do that, right? Like, so we tell people test your backups, but if you've got a ton of data, how do you do that?
So I don't think I got a terabyte backup before, but I am certain Vinodh saw it.
100 gigs? I mean, 200 gigs? It's still a lot, right? Like, so, I mean...
I won't talk about Mongo for this, but I had a NDB cluster before, and it was a scary story, as you imagined. So we have like 10 gigabytes of backup, and we tested them every week. Like we restored on a NDB cluster in some ad hoc NDB cluster and checked the latest data. And if we are okay, we said okay, because there will be a time you need to restore in a rush, and you will see you can't. So I think it's really important to have them tested. But for 100 gigs, a terabyte of data, I am not sure how to do it properly in a timely manner. If you have time, it's easier, but
time and resources, because I mean, in some cases, that's a lot of extra CPU and disk resources as well. And I think that from a backup testing backup perspective, we've preached this a couple times. I've had a couple people on podcasts over the last few months where we've kind of deep dived into this topic. But when you're talking about backups, one of the other interesting things is not just about testing; it's about understanding the importance and frequency about a sound backup strategy. I'm going to tell everybody. I could be snarky. Just ask the question. High availability and backups are two very different things. Replicas are not a backup. And the thing that I see people forget is when you put garbage into a system or you delete stuff in a system, those get replicated. And it's so important to understand that, because when you say, my system is too big to back up, I'm just going to rely on replicas. And we have had people that I have talked to who say that. They go, you know what? It takes us forever to do a backup. We're not going to do it. We've got HA. If we have a problem, we'll just go to our replicas. And that mentality is going to lead you to many nights being consoled by alcohol and, crying in a corner. It really is. So don't do it. It's very important to realize that, those are two very different things.
So one incident came into mind when you were talking about that one. So the one of this particular case where the customer was having a 1.5 I think like a 1.5 terabyte of oplog itself, okay, which is kind of a transaction kind of log.
Right.
So that collection is about like 1.5 terabyte, and they had to fail over primary, and they had to terminate the MongoDB, and they thought like it would come up within like half an hour or 15 minutes usually.
Oh,
But
yeah.
what happened, like it was actually doing reading the oplog for nearly like a 1 week back, and it took nearly 5 to 6 hours to for that particular instance to come up. Okay, this is an unexpected event, and again, like they thought like, okay, we will have this node for failover kind of thing, but again, for 6 hours their application was down.
Yeah.
So you have to
No,
be.
and I think that this is where I've seen this before, and I like to kind of phrase it where, your good intentions destroy you. Because there are so many people who don't fundamentally understand the technology that they're running. They do things that logically make sense, right? I've got
Yeah.
an overloaded system. Let me just try restarting it. And so what ends up happening, right? So, you've had this overloaded system. All of a sudden you've got to crash recover. You've got to do all this stuff and it, you take a problem that might have been a problem and you make it 10 times worse.
Yeah.
I've seen that so many times, right? It's crazy how often that happens, and it's that over engineering or overthinking, the solutions. Sometimes patience is the best option, even though no one wants to be patient when some of these problems happen. Other times, you're going to have to, bite the bullet and do some things that might be a little risky when it comes to restarting or doing some other things. But yeah, I mean, I understand that, if you've got a 1.5 terabyte or oplog, that's going to be some nasty stuff.
Yeah. That's there. Yeah.
Yeah, talking about disaster stories, I want to tell another thing that can use with cross-regional replication. Besides from migrating to Kubernetes, you can also configure a Kubernetes cluster. Or if your primary is in Kubernetes, you can configure a regular PSMDB cluster as disaster recovery site. Right now, it's not automatic in operator, but we have some plans to do that. But if you configure these 2 clusters or more than 3, 2 even, and the primary is it fails in some reason like hardware failure or network failure, you can fail over to the replica cluster. Yeah, you need to do some stuff to fail over to reconfigure the replica sets, because most of the nodes will be gone, and you need to do some forcing to new replica set config. But after that manual intervention, you can have relatively up-to-date data up and running easily with this new feature of PSMDB operator.
So you're talking about you have the cross geo setup, but then you can also fail over the replica sets. So it's like a double failover.
Yep. And you can make some nodes be selected as primary in replica cluster, and maybe you need to update your client applications to use that new primary, or maybe you have some stuff that you can move the IP to the new cluster, to new replica cluster, and you can have this disaster recovery scenario.
Oh, awesome. All right. Well, it looks like we don't have any questions in chat today. That's okay. I want to thank both of you for swinging by. We're going to go off now to our all-company meeting here at Percona, and we're going to celebrate the retirement of Tom Basil, our longtime Perconian. So we're going to go have some fun with that. But we appreciate people watching this, and hopefully, there were some interesting tidbits for you. Feel free to reach out over Discord or over chat if you have questions, and if you have ideas and things you want to see in future meetups, we'd love to hear about it. All right, everybody. Thanks.
Thanks. Bye.
Thank you.